Eilers.
And our video photographer is
Miss McAuley.
Ms. McAuley. All right. So what we're going to be doing today is our physical and chemical changes lab. All right. So we're doing it virtually, so you can still get the experience of having a little bit of fun here. Okay. At least we get to have some fun. All right.
That's all that matters.
All right. So the introduction, it says that chemistry is the study of matter and the changes it undergoes. These changes can either be a physical change or a chemical change. A physical change is when the physical properties are altered, such as size, shape, density, or state of matter. Okay? But the chemical composition will remain the same. All right, got that?
Yeah, so it's kind of like if you're taking a piece of paper and you go to rip it up, it's still paper, so it's just undergoing a physical change.
That's right. Good example.
Cool.
A chemical change results in the formation of one or more new substances. Signs of chemical changes include the formation of a new solid called what's snow? What's rain?
Precipitation.
Yes, very good. All right. Formation of a
gas?
Yes.
Okay.
All right. A bubble. Change in
temperature.
Yes. Good.
Now, is that if it gets hot or cold?
Well, what do you think?
Well, if it's a change in temperature, I would think it'd probably be either.
You are correct.
Okay.
Very good. And then sometimes a change in color.
Okay.
Now, a physical change might result in a physical or a change in color too. Like if you take a blue crayon and a yellow crayon, what do you get?
You get green.
That's right. That's a physical still. You're not changing its composition when you do that.
Okay.
Okay. But if you have like something clear and clear and you get yellow,
well, then that would be
a chemical change because clear and clear don't normally make yellow.
Right.
It makes clear. All right. So I'm going to ask you a couple questions, and you just tell me what you think is going to happen. Okay.
Okay.
So, do you think that burning wood is a physical or a chemical change? Think about burning wood.
Well, I'm thinking that if I'm burning the wood, I'm going to be changing that wood into ash. So therefore, I'm making it into something entirely new, right?
Right.
So if I'm changing it into something entirely new, then it has to be a chemical change.
That's right. That's right. I like that. How about ice freezing?
Okay, well, if ice is freezing, it's still water. So
Is
it's
it?
just going, it should be. I mean, I know it's crystallized, but it's still H2O.
Okay.
And I'm not making anything fancy off of it. I'm just freezing it.
Okay.
So if it's staying as water, then it's just gone from a different phase. So therefore, it's a physical change.
So the liquidy stuff is H2O, and the solid stuff is?
It's still H2O.
Okay. All right. I like that. What about water boiling?
So if it's boiling, it's just getting bubbly, and you might see some water vapor or the gas coming off of it, but I mean, it's still water.
How do you know it's water gas? How come it's not oxygen gas?
Well, because if we go to take something, you could either try to collect it off of the top. Let's say that you're doing like one of those apparatus things where you're evaporating water to get clear water.
Oh, okay.
Say it's like maybe kind of like with that distillation stuff that we were looking at. We looked at it in a different way.
All right.
So if you collected the water off the top of it, or the gas or the water vapor coming off, you would see water.
Okay, sounds good. What about sugar dissolving?
Well, I guess with that, we want to ask ourselves, can we separate it after that? So we could try to evaporate the water off.
Yes, we can.
And we'd be left with the sugar in the end.
That's
so
right.
Therefore, we haven't really changed anything, and it should be a physical change.
So you're saying separation is a physical change?
Yeah.
Okay, all right. Chocolate bar melting.
Well, is it still chocolate? I would think so.
Yeah, I'm thinking if I have chocolate Hershey's bar and a melted, it still tastes the same.
Yeah,
all
so
right.
it should be physical.
Okay, how about breathing? Take a deep breath. What do you think?
outside, so I'm breathing in a bunch of different gases. The one that's most common is going to be oxygen.
Okay.
And so my body is going to use that oxygen, and when I breathe out, I'm breathing out carbon dioxide. So I breathed in, or I took in one thing and I'm giving off another, so it should be a chemical change.
Okay, all right. So I think this is a good place to stop, and we're going to do some experiments then.
Great.
Next time we get together.
Okay.
Part one of the physical chemical change lab. So what the first thing we're going to do, it says safety, wear goggles and aprons at all times.
Check.
Check. All right. So part one, weigh the candle and the beaker together. Mr. Eilers, want to do that?
Sure. All right, so we want to always make sure we hit 0 to make sure that there's nothing on here, and we'll put that on there. We see that the candle's stopping around 135.32.
So, students, ChemStars, I wrote that down in my lab report. See, it says Chapter 1 Activities Lab, page 3. That's where I'm writing this down. And I'm going to put a little G here for grams, okay? So now what? We're going to light the candle. We're going to just leave it here on the scale. Oh, and there it goes. So, what do you observe, Mr. Eilers?
Well, so I can see that there is some kind of light being given off. If I take my hand, not put a little too close, but a little bit kind of up, I can definitely feel that there is a heat being given off. So there's some kind of temperature change going on there. If this was a candle from maybe Bath and Body Works, there'd be a nice little smell coming off of it too.
I can't smell anything. Can you smell anything?
Let me try. Yeah, so there's a little bit of an odor. Not quite noticeable,
yummy, like
but
Bath and Body Works?
not quite as great.
Okay.
But
Okay.
there is a little bit of it.
Okay, so odor. Anything else you notice? I'm kind of seeing, is there some liquid pooling down there?
Oh yeah, so we're seeing that the candle is going from the solid state that it was originally in, and it's starting to kind of pull and make a liquid in the middle, especially towards that
So
flame.
what is liquefying?
Well, if we take a look at it, it would have to be the wax. The wax, which is the hard
wax.
part of the candle, is liquefying.
Okay. So what's the wick doing?
The wick itself it looks like it's burning. And if you actually take a look in that little puddle, you can see parts of the wick itself have actually already kind of like fallen off.
Oh,
And
really?
I bet if we got to touch it, it'd be kind of ashy.
Okay. All right. Because it definitely turned color, didn't it?
Oh,
Because usually the wicks start off as white. And
Yeah,
now
and
the
it's-
wick is now
it's turned to black.
All right. So it says wait a minute. Do you think it's been a minute yet, Mr. Eilers?
It's been pretty close.
Okay, so why don't you go ahead and blow it out? Ooh, nice job. And now it says record the new mass. What is the mass?
Well, if we take a look at it now, it's 135.19.
Ooh, hey, it lost 13 grams.
Wow.
All right, so where did that go? Where do you think that 13.13 grams went?
Well,
Did you notice something? What was that?
the smoke?
Yeah.
Yeah, so part of it was being burnt off, and we saw that the smoke was coming off as soon as we blew
Yeah.
out the candle, and it was rising.
Yeah.
Yeah.
So what is smoke?
Well, isn't it like a mixture of carbon dioxide and stuff?
They're gases, right? Yeah. So I think we lost some gases.
Okay.
All right. So that is all we had to do for part one. All right. Hang on for part two. ChemStars, this is now part two of our physical and chemical changes, all right? I don't think we have to introduce ourselves, do you? They already know who we are. Okay, so it says measure out 5 mils of water. We have 5 mils of water, all right? And then it says put the water into a test tube. So we'll do that right here. All right, and Mr. Eilers, maybe you could hold on to this. What do you think? All right,
Yep.
so they can really see it. And then it says add a micro spatula. That's what this is. This is a micro spatula, just a teeny tiny scoop here.
Okay.
It doesn't take a whole lot. And put it in the water. All right, so what do you think we need to do now? Should we kind of like shake it up, maybe stir it a little bit?
Yeah, stirring actually adds an agitation which helps salt dissolve faster.
Okay, all right. Is it dissolving, do you think?
Yeah, if you can actually see, I don't know if it pops up good on the camera, but as I go to give it a quick swirl, you can see bits of the salt are actually breaking off and kind of going up in there.
Ms. McAuley, can you see that?
I can see that. Hold it in front of your black apron a little lower. Let me help it show up a little bit.
Okay, good. So we dissolved sodium chloride. So what's our observations? Let's write that. We have to write down our observation after mixing salt with water. So what would you call that? Is the salt still there?
Well, it is, but it's dissolved, so it's no longer in that
So
salt.
you can't observe. Oh, I like that. And so salt is no longer a solid. I'm going to write it disappeared. Okay, so I just wrote that down, okay, on my observations. Okay, good. Now it says add 10 drops of 0.1 molar silver nitrate. And the little thingy just came off. All right, there we go. We'll try it again. Now you may wonder, why is our silver nitrate wrapped up in this aluminum foil? Do you have any idea, Mr. Eilers?
Well, I know some chemicals react pretty harshly to light, so we probably are trying to preserve it so that way it doesn't kind of break down.
Very good, very good. All right, so I'm going to add, it said 10 drops. I wonder what would happen if I added 11 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can put 11 in. Ha! All right. Holy cow, look at that.
Oh, that looks awesome.
What is that?
Well, based off beforehand, that was our precipitate. So we have like a solid that's coming out of here.
We have a solid white, I'm going to put white solid.
Okay, so we got a white solid.
Now, let me ask you this. Do you think it's my sodium chloride that we put in there?
Well, I'm not exactly sure, but since we put in the silver nitrate, correct? I would probably assume it's probably a chemical with that.
Oh, okay. So it's not our salt coming back.
I don't think so.
All right. So if it's not salt coming back, this is probably a what? Physical or chemical then?
Well, for making something kind of entirely new, I would guess it would be a chemical.
Okay. All right. All right. So I think it's very, and also it looks a lot different than the salt did, doesn't it?
Oh yeah, it definitely does.
It's a lot chunkier in there. So maybe if we put it down for a little bit, if maybe in the next video we'll come back and see if maybe it's settled down. We can maybe look for that. Okay. So this is what I wrote down for part 2. And I think we're about ready to start part 3 in our next video. This is, we're back doing the physical chemical changes lab. Now we're going to do part 3. So we're going to start off with magnesium, and Mr. Eilers already has a 5 centimeter piece of that. And I want to talk a little bit, he's going to cut it up into 1 centimeter pieces, all right?
Okay.
So this is that same magnesium that was used for demo day. Do you remember when we lit the magnesium and it made this white, bright light?
If you're in the building, please call the front office.
Anyway, so this is the same material. Now we said it was shiny. It's very, very malleable, all right? And one of my students said it looks like a piece of metal. And you know, magnesium is a piece of metal. So Mr. Eilers is, now done cutting the magnesium. All right, so what would be your observation right now? We went from a...
Well, looking at it right now, it went from being a nice kind of like long strip to being cut up. So since it's still magnesium, it should be a physical change.
Okay.
And then taking a look at it too, we can see that it's shiny, it's silvery in color,
Okay.
and it's a solid.
Okay, so I put those observations. The only difference is you have smaller pieces, right?
Yep.
That's the only thing we did. All right, next what we're going to do, we're not going to light this on fire, all right, but we're going to add another chemical to it. It says place 1 piece in a test tube, all right, and I don't know if you want to hold this, all right, I'll try to be very careful. And then it says add 3 to 4 drops of 6 molar, here it is, of hydrochloric acid, all right? So this stuff is pretty dangerous. I'll try not to get it on you. All right, if it is, you're just going to drop the test tube and run and wash your hands off for 15 minutes, okay?
Okay.
Gotta think of safety, okay?
Yep.
So here we go. So 3 to 4 drops, right? 1, 2, 3, and put 3. Oh my goodness! Mr. Eilers, what's happening?
Well, if we listen really closely, we can hear some kind of gas being given off in like the form of sizzling. So hold on just a sec. Hopefully you guys can hear that on the camera. On top of that, we can see that there are some bubbles that are forming. We definitely see this like little gas that's rising up. So there's definitely gas being given off. If I give it a quick little poke, there's actually a temperature increase too, so it's getting warmer.
Did you burn yourself?
I did not,
Oh, okay.
but it wasn't too bad.
Got hot. Oh, wow, that's pretty cool. So, you know, wonder what that gas is. What do you think? I don't know.
I'm not exactly sure either.
You know what? Maybe in the next video we'll find out. But before we go away, this hasn't done a whole lot. We'll check this after video 4. This is our silver chloride, or silver nitrate with sodium chloride. All right, so we'll see you shortly. This is our last part for the physical chemical change lab. This is part 4 if you're following along. So it says place enough of the same hydrochloric acid, the 6 molar hydrochloric acid, into a test tube. We're going to use this one. So it's about a 1/2 inch in the test tube. So I'm going to pour this in here. Pretty close. All right, and now what? It is clean and dry. We made sure that ahead of time. And then it says place the remaining 2 magnesium pieces. I don't know. I'm feeling braver than that. Let's put 3.
3 of them?
Yeah.
Okay. If I can pick them up. Got them.
Okay. Put them in there.
Okay. 1, 2, 3.
All right. So now, do you see that gas coming up?
Yeah.
We're going to collect that gas. So the upside down test tube, all right, is actually going to be collecting that gas, because you notice that gas rises, all right, so it is less dense than regular air. So this top test tube is collecting that gas. Now remember how that last video I asked you, well, what do you think that gas is? And you said,
well, on the one with the candles, I was saying it could be like carbon dioxide.
Right.
Yeah, so
Right.
anything kind of like that, it's possible. It could be oxygen too.
it could be.
Fun stuff like that.
It could be. So what we're going to do, all right, is have the wooden splint test.
Okay.
So if it is oxygen, what I'm going to do, somehow, I'm going to take my mask off, I think, is that I am going to, well, actually I'm not going to blow it up. So I'm going to light this, okay? And if it gets a larger flame, it's oxygen gas.
Okay.
But let's see what happens. I don't want to ruin the surprise, okay?
I'm nervous. I
Are
haven't
you
seen
ready?
this before.
You've never seen this?
Not this lab.
Oh my gosh, you lasted all this time in your life without ever seeing this?
Yup.
Oh, you're going to be happy. It's going good. Why is this going out, Mr. Eilers?
Well, I can always try to find another splint if I need one.
That's good enough. You ready? You ready?
Yep.
How is it going to work? It's not going to work. I need a All right, so Mr. Eilers, we are getting a lot of gas coming up here. If you get the video camera down there, you'll see it's really bubbling and churning and being vigorous about something, all right? So we want to gather as much gas in here as we can, okay? And this is going to be good.
So Mrs. Vandewalle is going to light the splint, and when she says go, Mr. Eilers is going to help pull the test tube away on the bottom.
Right.
Does that sound good?
That sounds good. So, you ready?
Yep.
Hang on, I got this good. No, don't do it yet. All right, on your mark. Get set, go. Pull away. Oh. Ooh. Okay, it was a little chirp. On other times when this works out better, all right, maybe we should have collected it longer, but we're trying to keep this video short, you know.
Yeah.
It's a really loud pop.
Okay.
And some people have almost peed their pants.
Really?
Yes.
Well, I'm
It's
glad
pretty
it wasn't that
awesome.
loud for me.
Yeah, I know. All right, so that concludes the Physical Chemical Changes Lab. So what we'd like you to do is answer the conclusion questions on your own. All right? So don't wait to be great. We'll see you next time. Bye-bye.
See ya.